Okay, so page 70 has all the charges there. And so what we're going to have you do, is just write some formulas out based upon charges. That's all we're going to have you do. This is about the 4th time we've emphasized this, talked about these ionic compounds, kind of how they work. So that's what we're going to do real quick. It shouldn't take you very long to do, because all we're doing is balancing out charges, and I think most of you, this should be relatively easy. So what we're going to do is have you find calcium ion, and I want you to put it with iodine ion. Okay? And then write the formula out. So CAI. Go ahead and write that formula out. CAI, and how that's going to work. So Ca is a +2 on that chart, and iodine's a -1. So that would be what? CaI2. Is that what you guys have? Awesome. Okay, we'll just do one more, because I think you guys will understand how these go together. So we're just going to do one more. This is the one I want you to do. Is Al. Oh, we might do 2 more real quick. Do AlNO3. We'll do them together. AlNO3, and I got to do one that's I'm gonna have to use later on. So let's do PB and CO3. Let's do that one. Okay. So put those 2 together, if you would. AlNO3 and PbCO3. Alright, so we have AlNO3, so we got a +3 and a -1, right? So that formula would be Al with NO3 side by side, and then we have to determine if we need more of one of the 2. So how many we need? Which one do we need more of? Yes, Adam?
NO3.
How many? 3. Very good. Any questions of that? So good. A lot of times when we first started doing this, students were leaving out the 3. They weren't writing the 3. They were writing Al and then NO. They weren't writing the 3. So make sure you write everything out. And then PB is a +2, carbonate's a -2. You got to like that. Because now you don't have to do any work, but just put them side by side. PbCO3. Correct? Got it. So those are your ionic formulas. Those are all ions. And now the next thing we're going to do, we're going to look off of this list. Okay? This list I gave you. And what I want you to do is I want you to write the formulas on this list above their name. So where you see ammonium, write NH4 positive, okay, off of your list. So when you read, the bullets, down on the bullets, on that page I gave out, you guys got that paper I gave out, right? On that paper, I need you to write NH4 positive where you see ammonium. Just write it above it. Because most of you will not know the formula for ammonium and its charge. So you write NH4 positive. Okay? Here in a second, I'm going to bring that page up so that we can look at it together as a group. Okay, so here is the chart. And when I say put an NH4 above ammonium, okay, that's what I mean, the NH4, where it says ammonium cations. Right? So the NH4 in that first bullet, ammonium, you'll write NH4 above it. Positive. Okay? Nitrates, NO3, negative. Acetate, CH3COO, negative. Write those in. Okay? If you don't write them in, then you don't have the ability to write these formulas out like we just got done doing. You'll have to look on page 70. You'll have to get that chart sheet out. We don't want to do that. Okay? Now, chloride, bromide, iodine, they're all -1s, and they're just off the periodic table. So you don't have to do that. Mercury 1 is Hg, silver, you can get that off the periodic table. That's pretty easy to do. Then the last bullet says ionic compounds containing carbonates, which would be CO3 -2, phosphates, PO4 is -3, and then hydroxide is OH -1. Okay? So if you're getting this video and watching it at home and you weren't here, then you're not going to be able to see what I'm writing above carbonate, phosphates, hydroxide. You just have to make sure that you look at your chart sheet. When you come in, you can get this sheet from me and I'll get it to you. All right, any questions on that? So let's just go through this real quick. The first bullet, okay? The first bullet says ionic compounds in group 1 and ammonium cations are all soluble. Okay, Brock? It says that this first group here, okay, sodium, potassium, rubidium, that whole group, they're all soluble. It means if I have those ions present, they will dissolve. Noah? So all of these ions up here, that's group 1, they will dissolve. What's the other one that will dissolve if I have it? That's listed in that first bullet. Alexis, what else is in that first bullet that's not on the periodic table? What's that? Ammonium. So if it has ammonium in there and I go to dissolve it, it's going to dissolve. Anything with ammonium ions, it will dissolve a little bit. Okay, at least a little bit. Second bullet goes along with the first bullet and it says, hey, if you have these two negative ions, they're always going to be soluble. If you have an NO3 and a CH3COO, they're always soluble. Okay? They're always soluble. Any questions with that? Okay? Now we get into this third bullet and we've got some things that are insoluble, which means they'll form solids. Okay? So, if I have chlorides, bromides, and iodides, they are soluble unless, okay, unless, go ahead and circle that on your paper if you want to, unless, and then underline, silver, mercury, copper, or lead. Okay? Unless. What that means is that if we put silver with chlorine, it's insoluble. Okay? Let me show you what I mean. I'm going to get some tap water. Guess what it's got in it? Chlorine. Okay? How do we know it's got chlorine in it? We can do the silver test. The silver test is to take some silver ions, put them in there, and if it's got chlorides in here, it will form a solid. So that's what I'm going to do. I've got water out of the tap. I've got AgNO3. Let's put it in there and see what happens. Okay? So it's got some chlorides in there. And I imagine it's not the only thing that silver's reacting with. It's probably reacting with carbonates as well. Okay. So you're saying, well, does that happen to all water that you have? Nope. Take some distilled water. So in labs, sometimes we have to do with distilled water. Because if we do it with water, guess what? It's going to interfere with our tests. And it's not going to be good. So anytime it has distilled water, nothing. Yeah. So distilled water doesn't have the chlorines in it, doesn't have the carbonates in it. Regular water does, and you can kind of tell the difference. And as it sits, you can see it settles at the bottom. Okay? Where it's going to settle. So you guys get the chance to do some of these labs tomorrow with precipitates. Okay? Okay? No, you got a note here. Okay. Any questions you have? All right. Now we're going to practice using this. The last one that we need to talk about is that carbonates, phosphates, and hydroxides, they're pretty much always insoluble. Which means if we have them, they're not going to dissolve. They only dissolve, go ahead and circle it again, unless, there we go, unless they're combined with ammonium and group 1 cations. Okay? You guys are really got to pay attention today. And then get to 8th period, you guys want to sleep. Okay? It's not going to happen. Austin? Austin, get your hand up, please. Thank you. You know, I don't know how to, you know, I'm not going to make this fun and exciting to 45 minutes. It's not going to happen. All right? So now you guys get to be a little bit more active, and you guys are going to attempt to figure out if these are solids or not based upon what we just went through. Okay? So on the board, we have some ones we can test real quick. All right. So we're going to put parentheses behind this. If this is soluble, I'm always going to write AQ. Okay? If it's insoluble, I'm going to write an S. Okay? Tyler. If it's soluble, what will I write in parentheses?
Say AQ.
AQ. Very good. You were listening. Good job. And then if it's insoluble, I'm going to write a S for solid. Okay? S for solid. So AQ means it's a mixture, and S is a solid. Okay? So, make sure you do this. Melissa, make sure you write this one down, and you write either AQ or S in there based upon your rules. So look at your rules and see what it would be. Now, you may not find calcium. You won't, but you can find iodide as one of those bullets. And then I want you to read what iodide ions do, and if they're a solid or if they're aqueous. Okay? So if you wrote these down, we're just going to put it in parentheses, and then we're just going to go ahead and write it as AQ or S. Either or. Sound like true or false. This is a solid, yes or no. If it is, put an S. If it's not, it's aqueous. Rock, did you work on that one? CAI2. Look at your list. I think it's in the third bullet. It talks about iodides and what they do. And then we have that unless. Okay, so read that. Do I have an answer? Does somebody want to give me an answer? Yes, Zach.
Thank you.
You are right. Okay, because iodides are soluble unless they're put with silver, lead, mercury, or copper 1. We don't have any of those three. So that one's soluble. That one will dissolve. Okay? Next one. I haven't left much room on my board, but you have. Do the next two. And look at the next two. Decide if they are AQ, aqueous, or if they are a solid. Go ahead and do those next two, based upon your list. Let's do these two, and then I'm going to give you 6 to practice for 5 minutes, because I think if we do 3, I don't think that's enough to kind of cover all the rules. So the first one, Emma, you said was AQ is right, because all nitrates are aqueous. All NO3s, no matter what it's paired with, will dissolve. So what do you think I have most of my compounds in the back that I want to make up solutions? They're all going to be probably what? Made up of what kind of ions are going to be in it? Nitrates. Got a ton of I got a whole shelf of nitrates. Silver nitrate, lead nitrate, strontium nitrate. All those are nitrates. Can you look at your list? What would be another ion that would probably be pretty soluble that I'd have a lot of in the back? When you look at your list. What about acetates? They're all soluble, right? So I probably have a lot of acetates, and I don't have as much. I have more nitrates than anything. this last one, okay? Noah, what'd you get for the last one? PbCO3. It's an S. What did you use? What statement did you use? Right, unless. And this isn't an unless. Pb is always going to, with it paired with CO3. So it's a solid. Any questions of that? Is that pretty easy? You do that? All right. Okay, we'll see how easy it is. We're going to give you 5. If you get them all right, you got it down. If you get 4 of them right out of 5, not too bad. Anything less than that, there's some things you're not getting. So I'm going to put 5 up here, and you're going to do them real quick. Not real quick. You're going to go ahead and do them and see what you come up with, okay? Okay, so do those 4 real quick. Okay, Austin? You want to write those down? Well, just do those real quick. Say if they're soluble or insoluble. If they're insoluble, you write an S for solid. If they are aqueous, they dissolve. Well, they're soluble, they'll be aqueous. Okay? Let's look at these real quick. Okay, Austin, what'd you get? What'd you get for the first one? AQ is right. Are you 1 for 1? He's 1 for 1 anyway. AQ. Acetates. They're always soluble. That's in that first line. I think. Nitrates and acetates. Okay? Melissa, what did you get for ZnCl3? Soluble. So it would be AQ. Okay. But if you look on the 4th bullet, it says these are going to be insoluble unless they're with group 1 or ammonium ions. And carbonate's one of them.
Oh, yeah, I put S. Sorry.
Okay? S means solid. You're right.
Okay.
Yeah. So that's that one gets mixed up. Soluble is AQ and insoluble is S. But the S means solid, AQ means this makes a solution. It mixes up. Okay? Macy, what'd you get for NGBr2?
I got AQ.
You are right. AQ. Okay, good job, because bromides are all soluble unless they're with silver, lead, mercury, or copper 1. Tyler, what'd you get for Li3PO4?
The S.
You put S? Now, there's that exception. So when you first read that last bullet, it'll say phosphates are insoluble. Unless they're with group 1, which Li's in group 1, then they're soluble. Okay? So that should be AQ. That's a tricky one. If you would have missed one up to this point, it'd probably be that one. It says phosphates are insoluble, but if it's with group 1 elements, Li, Na, K, they're soluble. And then the last one, AGI. Selden, what did you get for AGI?
I put AQ.
AQ. Should be a solid. And the reason why is because it says iodides are soluble, but if there was silver, lead, copper 1, and mercury, they are insoluble. So those exceptions, these 2 last ones, these exceptions are tougher to kind of figure out. Right? I know you guys are wanting to put this up, but I got one last thing to show you. So please write this out, and we'll talk really brief about it, and then tomorrow we'll bring it back up. Okay? So write double displacement. Okay. So this is all online. It will be, this discussion will be online, and if you didn't take notes or don't have those, you can always go back there and look at them, especially for a test or a quiz that we're going to have. So what I'm going to do is I'm going to put 2 soluble substances, okay? I'm going to put Li3PO4, that's soluble, that's AQ, and I'm going to add it to Na. No, I don't want to do that one. I want to do shoot. I didn't want to make this too complicated. I think I made it too. So I'm going to erase this. I don't want to make it too complicated where we got balancing that we have to do. So I'm switching up gears, and I'm going to put HCl aqueous plus AgNO3 aqueous. Okay, you guys got that? So, this thing called double displacement. This is what you're going to do. There's two elements that are going to switch places with one another. H is going to go where Ag is, and Ag is going to go where H is at. And they switch places. So when they switch places, on the right side, H goes with NO3, and Ag goes with Cl. Okay, does that make sense? Double displacement. Okay, so let's look at doing the same thing we've already done, and we're going to go ahead and write down if it's aqueous or it's a solid. So write aqueous or solid in those two places depending upon what your table says. AgCl, HNO3. If it's soluble, write AQ. If it's insoluble, write an S. Now we also have to make, while you're looking that up, we also have to make sure charges balance out. +1, -1, they balance. Silver is a +1, chlorine's a -1, they balance. So it's okay to write one of each. Okay? I will do this reaction for you, okay, and show you what is going on to see if there's anything that is going to happen. So I'm going to take HCl and AgNO3, and we'll get a test tube. We'll put the Ag in it. And then we got the HCl. And if we put the HCl in the AgNO3, will they mix? No. Isn't that cool? A little lava lamp. Okay. So they don't mix. So one's a solid. Which one's a solid? HNO3 or AgCl? AgCl. Yep. Yep. So that's where you would write it, S. And then this one you would write what? AQ. And you have done a double displacement reaction. That's all you do. Double displacement. You just double switch the first one, make sure the charge is balanced, look them up. And now if both of these are AQ, do we have a chemical reaction? No. If you don't have a solid form, they're both AQ, there's no chemical reaction happening. Okay? Associated with that. Alright? Okay. Go ahead and get out your